So problem 18 section 1.6, if fx is between 3x and x cubed plus 2 for 0 less equals x less equals 2, find the limit x approaching 1 of fx. Well, look at that. X is approaching 1 and the interval of interest is between 0 and 2. 1 definitely lives here, so it's good interval. Now what do we do when we have three functions one below the other? This is when squeeze theorem gets applied. Okay, so you have 3x less equals fx less equals x cubed plus 2. Take limit x approaching 1 because that's what they want. X approaching 1 of the first function continues to be less equals limit x approaching 1 of the second function continues to be less equals to limit x approaching 1 of the third function. When x approaches 1, this becomes 3, and this 1 plus 2, that also becomes 3. In other words, limit x approaching 1 fx is between 3 and 3. So by the squeeze theorem, limit x approaching fx is equal 3. Something that's between 3 and 3 is just 3. So that's correct. Next problem. Okay. Limit x approaching 0 of x to the 4 cosine 2 over x. If I plug in x equals 0, I get a 0 here. But here I get something undefined, and cosine of undefined is undefined. So this requires some understanding. Notice, cosine of anything is between -1 and 1. I multiply all of these three functions by x to the 4th because that's what I want. X to the 4th is, mind you, because it's 4th power, it is greater or equals 0. For all x. So when I multiply by x to the 4, the inequality is maintained. So I get negative x to the 4 is less than or equals x to the 4th cosine 2 over x less than or equal to x to the 4. Now take limit x approaching 0 of the three functions. X approaches 0 of negative x to the 4th, x approaches 0 of x to the 4th, cosine 2 over x less equals limit x approaching 0 of x to the 4th. What happens here? When x approaches 0, this quantity goes to 0. This quantity goes to 0. So limit x approaching 0 x to the 4th cosine 2 over x is between 0 and 0. Therefore, by the squeeze theorem, this limit is equal to 0. Next. All right. Limit x approaching 0 from the right of square root x e to the sine pi over x. Again, let's plug in 0. That's a 0, but that's undefined. And sine of undefined is also undefined, let alone e to the sine undefined. So this requires some work. Notice I'm approaching 0 from the right. Why is that important? Look, we are under square root. If you're approaching 0 from the right, you are greater equals 0. You see, you cannot be negative. And that makes sense. You don't want square root of negative numbers. So let's understand this. Sine of pi over x is less equals 1. Okay. So I take exponential of this. So e to the sine pi over x is less equals e to the 1. E to anything is greater equals 0. So that's how I get my three functions. Now as x is approaching 0 from the right, x is greater equals 0. So multiply these three functions by x, square root x. Multiplying 0 by anything gives me 0. Multiply this by square root x. Multiply this by square root x. Now take limit x approaching 0 from the right of the first function less equals limit x approaches 0 from the right of the middle function and limit x approaching 0 from the right of the third function. The middle function I don't know, but the left hand goes to 0 right hand also goes to 0. See, e to the 1 is simply some number. Square root x, as x approaches 0, is 0. So 0 times any number, that gives me 0. So the middle function, I don't know its limit, but what do we know from here? This guy lives between 0 and 0. Therefore, by the squeeze theorem, limit x approaching 0 from the right, root x e to the sine pi over x has to be 0. All right, so that completes our section 1.6. Next videos will cover section 1.8, I believe. Okay, until then,